Alrighty. My demo is going to be probably very boring and not visual. But I've been sort of working to sort of continue some work that I've been sort of to allow for us to execute more complicated jobs in the orchestration layer. Um, One thing that came out of some load testing that we did at the end of the year last year was that maybe the implementation was not quite, the existing implementation wasn't going to scale quite as well as we were hoping. Um, so was looking into ways to improve the just to see if we could make some wins and to tweak a couple of things to make things faster in sort of that new implementation I'm working on. The answer was yes, and I said, okay, well that's cool, maybe I can make those same tweaks back towards the existing product too, to sort of make things faster there. So I re-implemented, and part of this was actually in the load testing to see if it was going to work for the future system. But I was playing with what would happen if we took the state store that we use to keep track of running queries and move it into Redis or Amazon's Valkey, and to see what would happen there. And at first, it worked really well. It was super fast. And then when I tried to throw some real load at it, I immediately ran out of space in Redis, and immediately, okay, not quite immediately. It was when I was putting in some pretty high load tests, but would run out of space in Redis and would start to really bog down when you had really large payloads. So think of like a really large SQL text and things like that. So I decided to turn on compression and to see how that would work. And it got significantly faster, as well as didn't run out of space, and it kind of performed admirably. And I said, well, what would happen if we just turned on compression for our existing state store as well? So I was playing with sort of some of these ideas to see what it looks like. So I kind of have two cases that I was looking at. And first was our existing state store Postgres with no compression, 5 tiles, no filters, basically just trying to bang on this as fast as I possibly could. I was running about 230 queries per second on the hardware I was on, which is not all that important, but it's the same across all of them. I just added compression both for Postgres and the cache index for here. It bumped up to about 252 queries per second. So a little bump, but not that crazy. I'll skip ahead and go to the larger things, the larger filter sets and larger queries. It dropped down pretty significantly to 88 queries per second with no compression. But as soon as I turned on compression, it bumped up to 170, so almost doubled there, or more than double, no, almost doubled. And then I wanted to try it out with the Redis implementation, both with the compression and the cache index compression. Immediately on the no filter set, significantly faster, 337 queries per second in this test. And then when I turn it on for the large ones, we see that it bumps up to kind of stays at around 300. It really doesn't bump down in the same way with these larger filter sets. We were just definitely running into problems with Postgres. It was slowing down. Sort of across the board, it's a lot faster at even some of the higher, percentiles. And I was able to sort of use that. There's a couple things that actually slowed down. So, for example, the cache write was a little bit slower in some of these, and that's largely because we're hitting it with so much more traffic that another system is starting to slow down. So, getting to play with some of these things, and hopefully these will come to a product near you soon. The really this only shows up under significant load, but will definitely help us scale better, faster in the future.